These notes are on radians. There are two ways to define radians. The first is to talk about radians being a measure of an arc length when the radius of the circle is 1. And so it doesn't matter the size of the circle when I'm finding the radian measure. I sort of act as if the radius is 1. The other way is to say that radians is a measure of the arc length divided by r. And remember that arc length is the percentage of the circle times the circumference, divide that by r. Percentage of the circle is some angle over 360. Circumference is 2 pi r divided by r. And that would then simplify to be some angle over 360 times 2 pi. The r's cancel. So we have two definitions of radians. One where we're talking about the circle having a radius of 1 and still looking at arc length. The other is to say that radians is an arc length, but when we ignore r, when we no longer have the radius no longer matters as part of our picture, as part of our equation. So first we're going to convert some degrees into radians. So using this formula, what I don't know is the radians, but I do know the degrees. So that's the angle, that's the degrees. So I would say radian equals x over 360 times 2 pi. And in this case, my x is 45. Plug 45 in. And then I start reducing these fractions. So I know that 45 and 360 are both divisible by 45. Turns out that that is 1 over 8. I also know that I can divide 2 and 8 by 2, which gives me pi over 4. So my radian measure is pi over 4. Our second example is 135 degrees. So again, I start with that same relationship. I've got my arc length times the circumference, sorry, arc length, no r, or r being 1. In this case, my degree measure is 135. And then I can reduce that fraction to be doing some quick calculations to make it a little easier on myself. 3/8 times 2 pi. Again, I can reduce this fraction. 2 and 8 are both divisible by 2. So I end up with 3 pi over 4. So my radian measure for 135 degrees is 3 pi over 4. Now we're going to convert radians to degrees. The same relationship holds. I'm still saying that radians is the arc length where I'm ignoring the radius or divided by r or treating r as if it's 1. In this case, though, we're not given a degree measure. We're given the radian measure. So I plug that in. And I'm solving for x now. I'm finding the degree. That's what they're asking for. Now, in order to isolate x, I'm going to have to multiply both sides by 360. That cancels the 360 in the denominator. But I'm also going to have to divide both sides by 2 pi. That's going to cancel the 2 pi in the numerator and denominator. So really, I'm multiplying both sides by 360 over 2 pi. On the right-hand side, that leaves us just with x. The 360s cancel each other, the 2 pi's cancel each other. On the left-hand side, I'm going to need to do some additional calculations. Pi divided by pi is 1, so I've canceled that. And 2 goes into 360 180 times. So I have 180 times 3 over 2. My pi's have canceled. But I also know that 2 and 180 can be divided by 2, which gives me 90 times 3. So I have 270 degrees. One way to say this is that 3 pi over 2 radians is equal to 270 degrees. It's like saying I am 5 feet tall versus 60 inches tall. Each of them, my height isn't changing, but the unit I'm using is. So a second example. We still have our radian equals our arc length, where I've divided by r, or I'm treating r as if it's 1. In this case, again, we've been given a radian measure, not a degree, so we plug in for radian. 2 pi over 5 equals x over 360 times 2 pi. Again, I'm solving for x, which means I'm going to need to remove the 2 pi and the 360 from that side, and I do that by multiplying by 360 over 2 pi on both sides. On the right-hand side, my 360 over 360 is 1, and 2 pi over 2 pi is 1, so I'm left with just the x. On the left-hand side, I'm in luck because not only do the pi's divide and cancel, pi over pi is 1, but it's actually the 2's do also. So I'm left with 360 over 5, which divides to be 72 degrees. So again, I can write this more formally to say 2 pi over 5 radians equals 72 degrees.